Welcome back to College Algebra, section 4.4, objective number 3. So in this lecture video, we're going to take a closer look at the even and odd multiplicity. So the objective here is finding the zeros of the polynomial function by applying the conjugate root theorem and the rational theorems. But we also will take a closer look at the even and odd multiplicity. So as you can recall, when I first introduced the even odd multiplicity, the multiplicity is basically the exponents on the factors of a polynomial. So if the multiplicity is odd, if the exponent on the factor is odd, then the graph will actually cross over the x-axis. Now, if the exponent is even, then the graph will actually turn at the x-axis. All right, so let's take a closer look. Before I do the even odd multiplicity, let's take a look at the intercepts and the degree. So just by looking at this problem, this polynomial function is already in the factor form. So all we have to do is just add up the multiplicity. So that's 2 plus 3 plus 1. So my degree will be 6. All right. So that means if I multiply this whole thing out, it'll be x to the 6th power plus something, okay, or minus something. All right. Y-intercept, as you can recall, y-intercept means find y when x is equal to 0. So if I will substitute 0 for x into my function, 0 plus 2, whole thing squared, 0 minus 3, whole things to the third, and 0 minus 4, then all I'm going to end up with is basically 2 to the third, 2 squared, negative 3 to the third, and negative 4 to the first. So once I multiply them up, that will be my y-intercept. So let's see what it is real quick. That's 2 to the second times negative 3 to the third times negative 4. So I got to put this negative 3 in the parenthesis, otherwise my sign will be off. So that would be positive 432. So my y-intercept, 0, 432. All right, so let's jump over to the next problem, okay? We'll come back to finishing this one. So for this problem, if I want to find the degree, that will be the highest exponent 3. All right, and the y-intercept is simply just by looking at this function and knowing that if I were plugging 0 for all the x's I see, then all these terms will be gone. So the y-intercept will be 0, negative 4. Okay, that's how I find, this is how I can find the y-intercept quickly. All right, so let's go back to this thing for first problem. The next step want me to find find the x-intercept at which the function f cross over the x-axis, and we will enter our answer as an ordered pair. So let me erase this real quick and take a picture of this so I can bring it down so I can take a look. All right, so finding the x-intercept or finding the zeros is very much the same way, but since this particular example, already factored for me, then I can quickly find the x-intercept. So I'm going to write down my x-intercept here, and I'm going to write down my zeros here, and I'm also going to write the multiplicity down here. So once everything is factored, we set each factor equal to 0. So one of my x-intercept is negative 2, the other one is 3, and this one will be 4. All right, so if I write down the multiplicity, that will be 2, 3, and 1. All right, so by the even and odd multiplicity, okay, if it's even multiplicity, then my graph will turn. All right, if it's odd, that means my graph will actually cross over the x-axis. Okay. All right. So where does it cross over the x-axis? So I kind of already know just by looking at the multiplicity on the factor. I already know these two will cross. So let me grab this function real quick. Parenthesis x minus, plus 2 to the second times x minus 3 to the third and times x minus 1. All right, I know by the leading term test, by the leading term test, there'll be scribble, 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 right side goes up, left side goes up because my degree is even, 6. So, okay, so this is what the graph looks like right now. Kind of strange looking. So what I'm going to do right now is just kind of play around with my window a little bit. I'm going to narrow down my x-axis a little bit. I'm just going to go from -5 to 5. Maybe the graph will pop out a little bit better. Oh, right here, it actually came all the way down here. All right. Okay, cool. So here are my 3, 0. It actually touched right here. 1, 2, 3, 0. So remember, I got a -2. I got a -2, 0, 1, 0, and a 4, 0. Okay, so select the option which display the text box needed to be complete your answer. So how many times? So this one is saying write down what are the x-intercept that the function will cross. So my answer, my x-intercept that you will cross, that will be 3, 0 and 4, 0. All right. Now comes the tricky part of the problem. What does it mean? What does it mean by flattens out? All right. So it turns out if we take a closer look, all right, at each one the 0. So I'm going to tell you what, I'm going to copy this again and bring it down here so I got my number in front of me. So let's take a closer look. All right. When x equal to 4, the multiplicity is 1. So it wouldn't right cross it, okay, at x equal to 4. All right. At x equal to, was it 4? Yeah, 3 and 4. Did I type in this wrong? X plus 2, x minus 3. Oh, shoot. I sure typing it wrong. Sorry about that. That's a 4 right there. No wonder my graph my intercept look kind of weird. All right. So at 4, it crossed right over. All right. At -2, right here, it turned. So I'm going to kind of just look at this part of the graph. Okay. I'm going to change my window from -1, excuse me, from -2 to -1. So we can take a closer look. -2 to -1. So what do it mean by flattens out? So I should not have done that. I should have done -3 to -1. All right. So can't really tell what's going on right here. Okay. But I'm going to go to the other one, x equal to 3. That one will be a little bit more obvious. So I'm going to go from 2 to 5. On the right side, see? All right, this is 3 when it crossed it. Right when it crossed, okay, right before it crosses, the graph appeared to be flattened. All right, it actually crossed it right exactly at 3. But before it crossed at 3, flattened means it appeared to be what? The graph appeared to be a little bit of flat right here, okay? But it actually never touched. It actually never touched the x-axis before it crossed. So what's happening right here is it just appeared to be flat, but it actually did not cross over at this point. It actually only crossed over the x-axis at exactly 3. So what's happening here is the y value are so small to the point where in the picture it looks like it flattens. Okay, so what the textbook wants us to say here about flattens out is every multiplicity that is greater than 2 is considered as a flattened part. Okay, the higher the degree, the flatter this thing will look. Flattened simply referring to the y value, okay, is so close to a 0 right here, it makes it appear to be flattened out. All right. If you don't believe me, we can go to second calc and actually just type in any number right before 3. So if I do 2.9, the y value is 0.0264. So it's so tiny, it makes it look like it's actually what? Flattened. All right. That's what they mean by that. So how many did I flatten out? 2 of them, because I got two x-intercepts that has a degree 2 and higher. So it flattens out at 3, 0, the x-intercept that flattens out at 3, 0, and the other one is this one, the negative 2, 0. So anything with degree higher than 2 is considered as flattened. So originally, the even and odd multiplicity simply talk about whether you will cross or you will turn. Okay, so take a closer look at exactly what's happening around the x-axis. It turns out that sometimes when the degree is high, even though it's an odd exponent, when the higher the number goes, the flattened it actually becomes. Okay, or the higher the even number goes, okay, the flatter it look right there at the x-axis as it turns. All right. So how many times did it cross? It actually crossed at 2 different places. Okay, 3, 0, 4, 0. It actually appeared to be flattened also at 2 different places, negative 2, 0, and 3, 0. So just remember, anything higher than the degree 2 on the multiplicity is considered as flattened. All right. So this particular example already factored for me. So what about polynomial that look like this? All right, it asked me to factor the polynomial completely. So now we are basically going back to do problems similar to this one. All right, but we also have to count the multiplicity so we can insert the cross over the flattened part. All right, so let's give this a try, okay? I'm going to do my P over Q. My P is 4, so what times what is 4? Well, 1 times 4 and 2 times 2. My Q is 3, so there's 1 times 3. So by doing my P over Q, okay, 1 over 1 is 1. 1 over 3 is 1/3. 2 over 1 is 2. 2 over 3 is 2/3. 4 over 1 is 4. 4 over 3 is 4/3. Okay, so these are my positive ones, so I can have a negative one. So I'm just going to put plus or minus right in front. All right, so all my potential rational zeros is going to be within positive 4 to negative 4. All right, so let's go see which one are my actual zeros. So the next step is plug into the calculator. So this is basically exactly the same thing as we done in section 4.3 when we finding the zeros. So 3x to the third plus 11x squared plus 8 minus 4 plus x minus 4. All right. Let me go back to the standard window so we can see. Zoom number 6. All right. Oh, you look like it turned right here and you cross over there. So let's find my actual zero. Negative 2 is 1. Just negative 2. Let me make sure I type in all right. X to the third plus 11x squared. Okay. Negative 2 was the first one I saw for my table. But what's the other one on the graph? What's this one right here? Well, I know this one that it crossed it is on the right side of the origin. So if you take a look, when x equal to 0, y value is negative 4. But when x equal to 1, the y value become positive. So by the intermediate value theorem, I should have a 0 between 0 and 1. So that will be either 1/3 or positive 2/3. Because 4/3 is actually bigger than 1. Okay? So let's check. So far I got x equal to negative 2. All right. So now if I go second calc and type in choose number 1 value, let's see, 1/3, 1 divided by 3, the y value is 0. So the other 0 is 1/3. Okay, so let's think about this. At 1/3, it crossed it. So when it crossed, it got to be an odd power. All right. So let's go to this right here. Negative 2 is the other 0. So I'm going to go to my window, take a look at from negative 3 to negative 1 to be sure that it actually turned. Because some picture might look like, see, this is the flat part I was talking about before. Sometimes a graphing calculator can show that it turned right there, but it can actually cross over the x-axis real quick and cross right back. So it doesn't. So it looked like it turned, but in reality, it actually crossed. So that's why I want to investigate specifically around right here. All right. So why do I put my window from negative 3 to negative 1? Because negative 3 to negative 1 will cover my negative 2 right in the center of my picture. So it turned at negative 2. Now, think about this. If the degree is only 3, turn has to be even. Cross is always odd. So what kind of even and odd number right here will actually make sense to give me a third power or to give my degree 3? So the odd got to be 1 power, all right, for the multiplicity. So the term part got to be multiplicity 2. That's how multiplicity 2 plus 1 will equal to degree of polynomial. So what does this got to do with factoring? Well, I already got my zeros, right? So just by looking at it, I know if I move my negative 2 over, that will be x plus 2, all right? If I would put, if I would move my 1/3 over, that would be x minus 1/3. Okay. Now, the multiplicity part, at negative 2, it turned is even. The degree got to be 2. All right. When x equal to 1, when x equal to 1/3 is odd, so my exponent is 1 right here. But x squared, if you think about this, x plus 2 whole thing squared is x plus 2 times x plus 2. So x times x will only be x squared. Let me write this out real quick. X times x is x squared. X squared times the next x will be x to the third. But this problem has a leading coefficient of 3. So my leading coefficient up front got to have a 3 on it. Okay? It's very strange why all we need is a 3 right here. There's a way to actually find it. Okay? Because you actually using the I can actually use the y-intercept concept. Think about this. The y-intercept needs to be negative 4. Right now, if I take 2 times 2, that's 4. 4 times negative 1/3. 4 times negative 1/3 is actually negative 4/3. Negative 4/3 is not negative 4. Okay? So, if I use my y-intercept concept that we learned previously, y-intercept means find y when x equal to 0. So if I put negative 4 where the y is, all right, set it equal to some sort of coefficient times 0 plus 2 is 2. 2 times 2, right? 0 for x right here. All right, 0 plus 2, 2. 2 squared is 4. And 4 times negative 1/3. Put 0 right here. Minus 1/3 is negative 1/3. So 4 times negative 1/3 will actually give me negative 4/3. So to get my leading coefficient by itself, I will have to divide both sides by negative 4/3. So negative 4 divided by negative 4/3. Negative 4 divided by parentheses, negative 4 over 3 will tell me my leading coefficient got to be 3. All right, so when I need to factor this polynomial completely, I actually do have a leading coefficient, okay, in front of all these parentheses. So that kind of match up what we talked about before with the linear factor theorem. Leading coefficient, all the x's inside the parentheses got to be 1x to the first power. Okay, that's what I got myself here. All right, so I figure I will go ahead and use the y-intercept concept to help us to find this leading coefficient. All right, so I got my third 3 power. Okay, I know where it's crossed, where it's flattened already, so I can quickly insert other parts. Let me move this up real quick. All right, so the x-intercept at which the function crossed, so it crossed at when x equal to 1/3. So that's only one cross. So the x-intercept will be 1/3, comma 0. All right, when does it flatten? So any degree higher than 2 is considered as flattened. So I flatten one time at the x-intercept of negative 2, comma 0. All right. So let's try another one, okay? Now, before I do this particular example, I want to go back and visit here some of these problems that we done in object number 1. So this particular problem, degree was 4, right? And you want me to factor the polynomial completely. So, and we also graphed it. We saw it cross over at negative 2 and negative 8, right? Along with the two non-real zeros right up in factor form, the exponent is 1 and 1. So that means the negative 9i and 9i already took up 2 degrees, already take up 2 multiplicity out of the 4. Therefore, the other 2, when they crossed, it got to be what? It got to be have multiplicity 1 and 1. All right. So sometimes we do need to watch out for how many times that we see the graph cross over the x-axis, or how many times it turn over that at the x-axis to determine the appropriate number of multiplicity. So, all right, again, factor this polynomial completely. If I do my P over Q real quick, Q is 1, so then all my potential rational zero will be all integers. So I can just go ahead and do my step number 2, okay, which is graphing, and see which one are my actual zeros. I didn't position these very well. Sorry about that. All right, x to the 4. 5x to the 3rd. Plus 25x minus 20. All right, let's graph it. Oh, sorry, go back to standard window. Oh, I see it cross one time. Cross, 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 cross. Oh, degree is 4, right? 1, 2, 3, 4. All right, so all 4 of these crossed. So now I just need to know exactly what they are. So let's look on the table. I saw 1, 0 crossed, 4, 0, 1, 0, 4, 0. That's it. 1, 0, 4, 0. Okay, I am looking at this thing crossover 4 times. 1, 0, 4, 0. So what's the other 2? Well, the other 2 cannot be non-real because the non-real zeros will never show up as x-intercept because they are not real. Therefore, the other two got to be the irrational zeros because they come in conjugated pairs. So if the other two got to be the conjugate, got to be the irrational zeros, then it kind of makes sense that the multiplicity for each one of my 4 0 got to all be 1. Okay, I just need to figure out what the other two is real quick. All right, so now I just need to go back to do my synthetic division to find out, to knock my 4 power down to a quadratic. So I'm going to go ahead and do this real quick. 1, -5, -1, 25, -20. I'm going to use 1 first. So bring down the 1. So that's 1 times 1 is 1. That's -4. That's -4, -5. This is -5. That will be positive 20. 1 times 20 is 20. Add them up, 0. So now this leading coefficient 1 is 1x to the third. So let's go through the synthetic division one more time. All right, I'm going to use the other 0, which is 4. All right, bring down the 1, that's a 4. 0, that's 0, -5. 4 times -5 is -20, that's a 0. So now this is 1x squared plus 0x minus 5 equal to 0. So quickly, this is going to move this over. That's going to be x squared equal to positive 5. So when I take a square root on both sides, the other two zeros are x equal to positive negative square root of 5. Negative square root of 5, positive square root of 5. All right, so it crossed it. All right, those two zeros as well. There you go, my multiplicity 4. So this problem, I have no terms. All right, so my final answer for factoring will simply be move the positive 1 over. That'll be x minus 1, x minus 4. Move the negative square root of 5 over. That will be x plus square root of 5. And my last one will be x minus square root of 5. There you go. Factored it completely. All right, so I'm take a picture of this, okay? So I can move it down to do my intercepts. So hopefully by now you can just kind of look at this polynomial function and already determined that the degree is already 4. And the y-intercept means find y when x equal to 0. So plug in 0 for all these x's that you see. So that means every one of these 4 terms will cancel out, so that leave you with negative 20. All right. X-intercept at which it crossed over at 4 different times. So 1, 4. Okay, forgot what the answer. 4 of them. So my x-intercept 1, 0, 4, 0, negative square root of 5, 0, and square root of 5, 0. All right, how many times was it flattened out? Well, none, right? Because every one of them crossed, so none of them flattens out. All right, so kind of take a closer look at what's going on with our graph when we're thinking about even and odd multiplicity. All right, that will conclude this lecture video. Thank you for watching.